Hello and welcome to this Unreal Engine tutorial. I'm the Fest Master, and today I'll be talking about making a force field material and door, a quick way of how to program that. Here, as you can see, the force field does fade as you get further away, and is quite translucent as you get close, and also when you click on it, it has a nice opening animation. With the way this code is set up, it doesn't close because I did it using the old interaction system, but it does have a nice glowing border to the opening area. Alright, so let's begin. I'm going to be using this project that we developed earlier that for interactivity demos. It has this door in it that can be interacted with and controlled by a separate actor. And so I'm going to be using that interaction system for this door as well. And you could use your own interaction system. The main parts of this tutorial are going to be setting it up to look the way it is. And to do that, I'm just going to create a new folder here and call this ForceField. And this force field door material and whatnot can be used for static force fields as well. So first we're going to need a couple textures. Well, three in particular. One of them I'm going to be making in GIMP, and the other two I'm going to be making in Substance Designer. So first I'll be opening GIMP. And now with GIMP open, I will just make a new file of a 1K image, and I will be grabbing the, where is it? Gradient tool, and doing a radial gradient. Not that direction, about there, out from the center, like so. I think that's the direction I want it. Oh no, I do want it black in the middle. So black in the middle, out to the center, but making sure the edges are all white. And then once that gradient is set up, just enter. Then now I'm going to grab this smudge tool, crank the side of the brush, and just go in here and just start mixing it up. And this will make the this gradient is the mask for the force field opening and closing. And smudging it like this will basically, well, something is wrong with this gradient. Let me make it again. Oh, that would be it. Interesting. Well, that'll have to do. But anyway, smudging it like so will just make it irregular and seem more of like a natural flow of opening and closing. Alright, now there we go. It is done smudging, and I will just export this to a file. We'll call this force field mask. And there we go. We are done in GIMP. Discard changes, and I can now import this into Unreal. And next I will be going into Substance Designer. Alright, so here in Substance Designer, I'm just going to create a new substance, and I do want this to be an empty substance because it's not actually going to be using much. We're just making masks, and I'll click OK. And I'm assuming a general basic working knowledge of Substance Designer here. So the first piece that I want to get out of here is a sort of cells looking thing. So I'm going to grab cells 3. Is cells 3 the one that I want, or is it cells 2? Cells 2, not cells 3. And then I will be taking this into a levels to invert it because I want the cracks to be white. And then putting it into a bevel and decreasing the bevel distance. Do something like that. Blur it a bit more. And then I think I'm gonna scale this down as well. So yeah, about there. Then in this final project, I'm just going to save this image out. And I will call this ForceField cracks. And the other texture we need is just a simple purlin noise. So let's see, black and white spots 1 should do it. Scale that up a bit. Pop it into a levels. And just balance it to be a little bit brighter. And then save that out as purlin noise. And that is all we need to do in Substance Designer. And no, we do not need to save the changes. And now we can import these 2 images into Unreal and can start making the material. So right click, create a new material, call this ForceField master, because this material is designed to have instances made of it. The first thing we want to do is, with this main node selected, we want to change it from opaque to translucent. And now there will be a good number of steps to getting this material working. It's quite complicated. So the first thing we'll need is a texture coordinate node, and just leave this as is, and then hold V and click to get a vector parameter, and we'll call this tiling and offset. And we want to set this color to be red in 1, green in 1, blue and alpha in 0, unless I'm sorry. We want this to be 0.2 and 0.2. So this, and then we would need 2 appends. And I want to append the red and the green together, and the blue and the opacity together. And then hold click for a multiply and A for an add. multiply the blue and green append by the texture coordinate and add the the red and green by the texture coordinate and add the blue and opacity. And what this does is this will allow us to offset the image in the blue and alpha channels and scale it in the red and green channels. And then we need a texture sampler, and the texture we want for this one is our ForceField cracks. So I selected it in the content browser, and then I used the selected asset from the content browser. So that is the first part of this. Now we're going to need to grab another texture coordinate, and we want to make a scalar by holding S and clicking, and call this animation tiling, and multiply the texture coordinate by this value. And then we want to get a texture object. And then if we select our Perlin noise, we want to have that be what our texture object is referring to. Now if we hold P, we can click to get 3 panners, and then we want to bring this multiply into the coordinates of each. The first panner I set to a value in speed y of 0.1. The second I set to 0.1 in the x. And the third I set to negative 0.1 in both. And then now I'm going to hold T and click for 3 texture samplers. And I'm going to plug this texture object into all of them, and the panners into their UVs. And now I'm going to want to hold A and get 3 add nodes, and then hold 1 to get a one-dimensional constant and set it to be 0.3, and then grab the red channel from these images, put that into the add, and then put the 0.3 value. And depending upon how your image is, you may need to tweak this value. And then holding O, make 3 1 minuses. And if you don't know, what these nodes do is they return the result of 1 minus the value going in. So if it's in the range of 0 to 1, it inverts it. Now holding A to get 2 add nodes, we want to add the first and the second together, and that gets added to the third. And then we'll search for subtract. One constant of with the value of about 0.8. And then a saturate node. Now we want to take, I'm just going to comment these areas so it's easier to use them. And now we want to multiply the red channel of our image from above with this value. And then actually multiply it again by 0.5, and we can just set that here in constant B, and then add 0.1 to it. And now if we hold V, we can click to get a vector parameter and call this color. And this will be the main color of your force field. I'm going to set it to red. And now if we get a multiply node and drag the result of the add into the bottom and the top into that color, we can connect that. And then for the final seriously complicated part, actually, I'm just going to copy this tiling and offset with the texture coordinate system and paste it again down here and rename this tiling and offset, but adding for dissolve. And this one I do want to set to 1, 1, 0, 0. So it's a straight yellow color. And then we want to get a texture sampler and set this to the dissolve. And then plug this into the UVs. And then, off of the red, I want to add a value of 0.5 to it, clamp with the max at 1.3, subtract and then we want to get a scalar parameter value called dissolve amount. And this scalar will control approximately how much of the image has dissolved, and multiply this by 1.3. That is not the node I want. I want to saturate. Saturate plugged into the subtract, and then another subtract, subtracting 0.1 from it, get the absolute value, copy the subtract because we're going to do the exact same thing, subtract 0.1, multiply that by how much? -3. Copy this subtract, or not subtract, saturate, and then hold A to get an add. We'll plug the saturate into B, and this A into the previous saturate, and hold M for multiply, and this value needs to be 4. Now the result of this multiply we will be doing something with, not at the moment. And then we'll hold M for another multiply here, plug that into the add, set its value to be 2, and saturate again. So saturate clamps the value to being 0 and 1. It's a very simple thing to do. It's essentially, as the tooltip says, it's essentially free on most graphics hardware. It costs no rendering time to include that. Alright, so I will comment out this section as well, just for the ease of moving it around. Here, after we've added 0.1, we actually need to make another add, and I'm going to control click and move this wire into there. I forgot to put this in earlier. This add needs to be plugged into, the B of this add needs to be plugged into our multiply here. And then the result of this add, as well as going into this multiply, needs to go into another add, and then a multiply. And then the B of this multiply is the result of this saturate. And then we'll create another multiply up here and plug our color into the A, and the B will also go into this saturate. So the purpose of all of this math is to both allow you to basically grab a point along this and say everything below this is black and everything above this is white, or slightly off-white and then put a highlighted ring around that center area. And then now I will grab a depth fade, if I can spell. Not that depth fade, camera depth fade. And plug a couple one constants into it. The first one will be set to 1000. And plugged into fade length. The second will be set to 100. And plugged into fade offset. And I will multiply this by -1. And add about 0.6. This gets plugged into the add here. And now this bottom multiply is plugged into opacity, and the top multiply is plugged into emissive and base color. So now if we go and save, we'll be able to see the result of our work here in the material viewer. And I'll put it on a cube so it's a little bit easier to see. Well, something is not right here with these purlins. Perhaps I've done something. Ah, that's what it is. The animation tiling needs to be set to 1 because it's only grabbing a single pixel of it instead of an area. Just go to save this again so it'll compile faster. And there you can see now we have this force field where there's brighter spots along like these crack lines, but they don't follow it perfectly and seem to move around. And then you can take this animation tiling, bring it down, or up as you see fit. I'm going to just leave it at 1 and save that again because I changed it. And the way you would want to use this in the world is to actually create a material instance for it and open that up, and then set values from here. Like you can go and make it a blue force field. You could change this value to, let's say, like 1.5 and make it look a bit more interesting. And I'll just go in here. If I check dissolve amount and we pull this up, that's our dissolve what it looks like. And this will change depending upon how you make your gradient. So I will just reset this dissolve amount to 0 and save that. And now we need to make the blueprint for our door. So I'm going to make a new blueprint class, base it on a static mesh actor. And I did not intend to call it new blueprint. I want to call it ForceField door. Now in the class settings, well, let's see, what was the interface? Interaction interface, that's what I called it. Add the interaction interface and compile. And with this component, I'm going to select, oh, I do not have it in here. Well, that's interesting. So I'm just going to go and import what I need. This is exactly the same as you would find in the starter content, the wall 400 by 400. Because I don't have starter content in this project, I don't have it here. But fortunately, I have exported it so I could edit it and do things with it. It just won't have that in the material. But this is the mesh that we are going to use for the ForceField door. Again, it's the exact same as the starter content version. And now, with this selected, we actually want to go select our wall, go to our material instance, and click the little teapot so that we can view this mesh itself in here. And the reason is, if we drag up the dissolve amount, we'll notice that it's doing it weird. So if we check tiling and offset for the dissolve and set this to be about 0.25 and 0.25, and then drag this offset to be 0.75, we'll actually get that dissolve centered on the force field. And that's one of the reasons that you want to use a material instance. So we will search for ForceField master instance and put that on our plane here, or wall. Compile this, and now in the event graph, what we want to do is get our interaction event and do a flip-flop. Actually, before that, in the construction script, we want to grab our static mesh and create dynamic material instance. Set the source material to be ForceField master instance, and then take the return variable, promote to variable, and call this material. And then with this we can set material and set the material to that. And now in the event graph, make the event interact, a flip-flop. Then we want to make a timeline and call this door. Now opening this timeline, we want to set the length to something short, so I'm going to set it to 0.5 seconds and create a new float track. Add 2 keys to it. The first key, time 0, value 0. The second key, time 0.5, value 1. And then if we just rename this, we'll call it lerp. And so for the flip-flop, we want to set the first one to play from start and the second to reverse. No, we want the second to be reverse, the first to be play. And on the update, we want to grab the material, set a scalar parameter value. Now if we go over to our ForceField master, we can get this, and we want to call this dissolve amount. So copy that and just paste it in there. Easy to do it, no problem. And set the lerp value. And then on finished, we want to, well, off of direction, we want to search for switch on timeline direction and plug the executable into finished. Now, if this is forwards, we'll want to grab this static mesh component, well, and set collision enabled to no collision, copy this, set collision enabled, query in physics. Compile. And then if we drag our blueprint into the level, just put it here, and then I will grab this little door control system and okay, how did we build this door control system? Open that blueprint editor, door, change it to an actor, change the variable type, event interact, that's what it is. Never mind. I do not want to do that. So if I go and play, I just have to click on this to get it to open, and since I built it in here quickly instead of using a better interaction system, it will only be able to open, it won't be able to close. A better interaction system that makes it operate more like this door, where it's a reference to it from something else, will work. And so if we go in here, we'll notice that the force field fades as you get further away. That's one of the features of this material. And then it gets quite translucent up close with those force field lines and can be opened. So that's the gist of this force field here. Alright, I thought I should put this disclaimer in at the end. All my values are based on these images, which are not the ones that I use. I made these separately. Well, I didn't make this one. This comes with starter content. And so you should be tweaking them to fit whatever image you use. As you can see, this one does not have a huge black area. It's much more of a smooth gradient. This is a much more detailed image. So you should be tweaking all the different variables that is used in this material to fit the images that you use. Because it is a tutorial and I didn't want it to be several hours long of me tweaking variables and checking it, I didn't do that. But when you do tweak it, you can make it look much better than it even does here. So I thought I should get that out of the way. And thank you for watching. I will see you next week.